A stone wall stands so perfectly fitted that not even a blade of grass can find its way through. This is the work of the enigmatic builders of the Andes, a legacy of lost engineering that defies our modern understanding. By the end of this journey, you will discover why the techniques behind these ancient marvels remain stubbornly out of reach for contemporary science. How did civilizations without iron or the wheel move 100-ton stones across mountains? What forgotten knowledge allowed them to construct buildings that dance gracefully through earthquakes? The answers challenge everything we assume about technological progress. What does it truly mean to build something that lasts 1,000 years? To build here required more than strength. It demanded a profound dialogue with the land. The Andes are a landscape of extremes where the earth itself is restless. Tectonic plates grind against one another, making powerful earthquakes not a rare disaster, but a regular feature of life. The slopes are punishingly steep, the thin air makes labor exhausting, and the weather can shift from blistering sun to freezing rain in moments. This was the relentless canvas given to the ancient builders. Yet they did not see a hostile world to be conquered. Instead, they perceived a living, breathing entity known in their worldview as Pachamama, or Mother Earth. Their relationship with this formidable environment was not one of struggle, but of intricate partnership. This perspective shaped every single decision they made, starting with the very bones of their constructions, the stone itself. They did not import exotic materials from afar. They used what the mountain provided: andesite and granite, stones born from the volcanic heart of the same restless range. This was a choice of deep intelligence. These local stones were not just durable, they were familiar to the land's movements. The builders understood, perhaps intuitively, that a structure made from the mountain's own substance would be more likely to move with the mountain during a tremor rather than shatter against it. But the selection went beyond mere physics. In their belief, these stones held the spirit of Pachamama. To build with them was to weave the living essence of the earth into their temples and fortresses, creating spaces that were spiritually anchored as well as physically sound. So, before we marvel at a single fitted joint, we must see this foundational truth. They listened to the mountain, and in return, it taught them how to build for eternity. This symbiotic wisdom sets the stage for the first technique that leaves modern engineers utterly perplexed: the art of moving the immovable. The stones themselves seem to defy logic. At the fortress of Sacsayhuamán, you are not looking at a wall of neat, rectangular bricks. You are witnessing a geological mosaic, a tapestry woven from giant, irregular boulders. Each piece possesses a unique, multifaceted shape, with anywhere from 6 to 12 or more sides, and no two are identical. This is polygonal masonry, and it represents a construction philosophy so alien to our modern mindset that it continues to baffle engineers. We are accustomed to blueprints, to standardized parts, to the idea that complexity is solved by breaking things down into simple, repeatable units. The Inca builders did the opposite. They embraced complexity at its source. They took these colossal, naturally fractured stones and transformed them into a three-dimensional puzzle of staggering scale. The process defies simple explanation. How do you shape a 20-ton granite block to fit perfectly against 3, 4, or 5 other uniquely shaped neighbors? The prevailing theory is one of meticulous, incremental fitting. Imagine stonemasons using smaller, handheld stones to peck and grind the surfaces, slowly working the lower stone until the upper one could be test-fitted. Then they would lift the upper stone, adjust the lower one again, and repeat. This was a conversation between stones, a slow dance of trial and error that required an almost intuitive grasp of geometry and pressure distribution. There were no formal drafting tools, no written mathematical formulas for such irregular forms. The blueprint existed in the collective mind and skilled hands of the builders, a knowledge passed down through generations of working directly with the mountain's bones. And this leads to the most ingenious aspect of their design, its relationship with the Earth's tremors. Because they used no mortar, these polygonal walls are not rigid. During an earthquake, the stones are free to shift and sway minutely against one another. They dance with the seismic energy, dissipating it through countless tiny movements across their complex joints. When the shaking stops, gravity simply settles them back into their original, interlocked positions. Modern engineers call this principle base isolation, and we spend millions designing sophisticated rubber and steel systems to achieve a fraction of this ancient, elegant effect. So we are left with a profound question. What kind of knowledge system produces builders who can see the solution to a seismic threat, not in resisting a force, but in designing a structure that gracefully, intelligently moves with it? To answer that, we must look at the tools that made this possible, and here the mystery takes an even stranger turn. This leads us to the second great enigma, a legend that speaks of stone not just being carved but being tamed. Among the most whispered theories is that of a lost botanical secret, a liquid brewed from plants that could temporarily soften granite, allowing it to be shaped as easily as wet clay. Early Spanish chroniclers wrote down these local accounts with a mix of skepticism and awe, describing a substance that made the impossible seem mundane. In the modern day, researchers have investigated certain native plants, like the sap of the puyo plant, which contains mild acidic compounds that could, over immense time and with constant application, very slowly etch a stone surface. Yet, the mainstream archaeological view remains one of immense, patient labor. The accepted method involves using handheld hammerstones, often made of a harder rock like quartzite, to pound the surface of a granite block. This isn't a dramatic chiseling, but a relentless, percussive pecking that gradually pulverizes the crystalline structure, grain by tiny grain. Combined with abrasion using sand and water, this technique can indeed produce smooth surfaces and even gentle curves. But then you stand before certain stones at sites like Ollantaytambo or in the heart of Cusco itself, and the theory of pure percussion begins to feel incomplete. You see blocks with flowing, concave depressions that cup other stones, or surfaces that swoop in elegant, continuous curves. The stone does not look fractured and pounded, it looks sculpted, almost poured into place. This creates a fascinating standoff between empirical science and persistent lore. Could the truth be a combination of both? Imagine a master builder using a plant-based solution not to melt stone, but to subtly weaken its surface, making the long hours of pecking and grinding significantly more efficient. This would be a form of organic technology, a chemical accelerant born from an intimate knowledge of the local ecology. It suggests a process where the boundary between working on the stone and working with it becomes beautifully blurred. The very persistence of the legend points to a deeper truth, that the methods of these builders were so advanced, so seamlessly integrated with their environment, that they appeared to later observers as nothing short of magical. But shaping the stone was only half the battle. The true test of their genius, and perhaps their most baffling achievement, was how they convinced these multi-ton giants to climb mountains. The greatest stones were not found at the building site, they were summoned from distant quarries. To stand before the Sun Temple at Ollantaytambo is to witness a feat of logistics that borders on mythology. Here, rose-red andesite monoliths, each weighing more than 100 tons, rest serenely high on a mountainside. The quarry for this stone lies across a deep valley, on a slope of a different mountain, separated by the roaring Urubamba River and miles of brutally steep terrain. The wheel was unknown here, and there were no beasts of burden strong enough to pull such loads. Every ounce of force had to come from human ingenuity and muscle. So how did they do it? The prevailing theory is a symphony of coordinated labor, a kind of slow-motion ballet enacted by thousands. They likely constructed massive earthen ramps, packing soil and stone to create gradual inclines up the mountainsides. To move a single block, teams would have used ropes woven from tough grasses, pulling in unison. Some researchers suggest a system of log rollers, constantly placed ahead of the stone's path, though this becomes perilously difficult on slopes. Others point to the possibility of a slideway, a prepared track lubricated with wet clay to reduce friction. The coordination required is staggering to contemplate, hundreds of people moving as one, guided by rhythmic chants or drumbeats to synchronize their pulls, inching a piece of a mountain across a valley and up its side, day after day, month after month. This was not brute force, it was brute force perfected into a high art. It speaks of a society capable of marshalling and sustaining immense communal effort, not through coercion, but likely through shared purpose and belief. The stones were not mere building material, they were sacred embodiments of the earth, and moving them was a devotional act. This context gives weight to the more enigmatic accounts passed down, stories that say the stones were made to walk, guided by sound or song. While we may interpret this metaphorically as the power of coordinated human rhythm, it underscores a truth modern engineering often overlooks: the psychological and spiritual dimensions of monumental work. The final act was as precise as the journey was long, placing a megalith onto its prepared foundation, aligning it perfectly with its neighbors without modern cranes or hydraulics, would have involved another masterpiece of leverage, using timber cribbing, ropes, and gravel fills to raise and lower the stone with painstaking control. The entire endeavor represents a lost science of logistics, a way of optimizing human energy and simple physics to achieve what our machines do today. It forces us to ask, what are we missing when we try to model such achievements with our computers? The equations can calculate force and friction, but how do you quantify a community's unified will? This seamless integration of spiritual purpose, social organization, and physical mastery reaches its most mysterious expression in a final, haunting question: what was the ultimate goal of such impossible labor? The true purpose of these monumental efforts becomes clear when you stand in the right place at the right time. The builders did not just master stone and slope, they mastered time and light itself. Their structures were not isolated feats of engineering, they were integrated components of a vast living observatory, meticulously aligned with the cosmos. At the Coricancha, the golden temple at the heart of the Inca Empire in Cusco, sunlight would pierce specific niches only on the morning of the June solstice, illuminating a sacred stone with a beam of light. At Machu Picchu, the carved pillar known as the Intihuatana, or hitching post of the sun, casts no shadow at solar noon on the equinoxes, a perfect alignment with the celestial equator. This was not decorative symbolism, it was high-precision science carved in granite. These alignments functioned as a colossal, immovable calendar, marking the critical turning points of the solar year that dictated planting, harvest, and ceremonial cycles for an entire civilization. The architecture itself became the instrument, a permanent record of celestial mechanics that governed survival, but their cosmic vision extended beyond the sun. Many sites are positioned along precise alignments, known as sec lines, that radiated out from the Coricancha, connecting temples, springs, and mountains in a sacred geography. Major constructions were often placed in direct sightline with revered mountain peaks, or apus, considered powerful protective deities. This suggests the builders possessed a form of geodetic knowledge, an ability to survey and map their empire not just for political control, but for spiritual and energetic harmony. They saw the landscape as a network of sacred relationships, and their architecture was the means of activating and honoring that network. For modern engineers, this presents a profound disconnect. We possess tools like GPS that can map a continent with centimeter accuracy, but we rarely, if ever, design a building where its structural integrity is fundamentally intertwined with the summer solstice sunrise or the profile of a distant sacred peak. Our parameters are load, stress, and cost. Theirs were a blend of cosmic timing, earthly energy, and communal belief. This integration points to a philosophical framework where the built environment was a conscious mediator between humanity, the earth, and the heavens. The stone was not just cut, it was calibrated. The wall was not just strong, it was spiritually resonant. This harmony of purpose raises a final, unsettling possibility that the ultimate secret of their engineering was not a single lost tool or technique, but an entire way of seeing the world, one where every stone held a place in a cosmic order we have long since forgotten how to read. Their architecture did not just stand on the earth, it learned to breathe with it. In a landscape where the ground itself is prone to sudden, violent shudders, the builders developed a principle so advanced we are only now giving it a modern name: dynamic architecture. They understood that to survive a quake, a structure must be allowed to move, to sway, to dance without breaking apart. This philosophy is etched into the very shape of their world. Look at any classic Inca doorway, window, or wall niche. You will not find a perfect rectangle. Instead, you see a distinctive trapezoid, wider at the base and narrowing gently toward the top. This is not merely an aesthetic choice, it is a stroke of seismic genius. When seismic waves slam into a rectangular opening, the force concentrates at the vulnerable 90-degree corners, creating points of extreme stress that can crack and crumble. The trapezoid, however, guides that energy outward and downward, dispersing it along the sloping sides and into the sturdy foundation. It turns a potential point of failure into a pathway for dissipation. This simple, elegant geometry is a masterclass in redirecting chaos, but the innovation goes deeper than shape. Remember those intricate, mortar-free polygonal walls. In a modern brick building bound by rigid cement, an earthquake's energy has nowhere to go, so the wall tries to resist until it shatters. The Inca wall, however, is a community of interlocked stones. When the earth trembles, each stone is free to shift and wobble minutely against its neighbors. They absorb the shock through countless tiny movements, a collective flexibility that a single, solid slab could never achieve. When the shaking stops, gravity simply settles each stone back into its custom-fit pocket. The entire wall acts as a monolithic shock absorber, crafted from 1,000 individual pieces. They even considered what lay beneath. At many sites, archaeologists have found foundations built with deep layers of crushed stone or gravel. This served a dual purpose: drainage to prevent water from softening the ground, but also a clever buffer. During intense shaking, these loose layers can compact and shift slightly, further isolating the structure above from the worst of the ground's movement, a primitive but highly effective form of base isolation. Today, our seismic engineering is incredibly sophisticated. We design skyscrapers with massive pendulum dampers that swing to counteract sway, or complex lattices of flexible steel meant to bend without breaking. These are active, high-tech solutions requiring constant maintenance and exotic materials. The Andean approach achieved a similar, and in many cases superior, longevity through passive design, using nothing but intelligently shaped stone and a profound understanding of geometry and physics. Our building codes are still striving to fully emulate the resilience they built into every structure as a matter of course. This level of inherent flexibility could not have been discovered by accident. It speaks to generations of careful observation, of watching how earlier structures failed and adapting, of developing a deep, intimate conversation with the tectonic personality of the land itself. They learned to listen to the mountain's tremors and answer with architecture that could sigh with the strain, then stand tall once more. This legacy of resilience forces a humbling comparison. one that reveals a gap not in our technology, but in our very approach to permanence. Water was never merely a resource, it was a sacred thread woven into the fabric of their world. While their stonework defies gravity, their true genius flowed with the mountain springs. At Machu Picchu, the silent symphony of their hydraulic engineering is still performing today. A masterful network of stone canals and channels captures pristine water from a natural spring high on the mountainside. Using nothing but gravity and a precisely calculated slope, they guided this water over a distance of nearly half a mile through 16 ceremonial fountains before finally releasing it into terraced agricultural fields below. Every drop had a purpose, a journey planned with mathematical certainty 5 centuries before modern plumbing. The slope of each channel is so exact that the water moves swiftly enough to avoid stagnation, yet gently enough to prevent erosion of the stone conduits. Drainage was an equal priority, with layers of crushed rock and cleverly placed runoff channels built beneath the city's plazas and foundations. A hidden system that has kept the entire mountain city from washing away through centuries of torrential rains. On a purely technical level, modern civil engineers can study these channels and understand the physics. We can calculate the flow rates and admire the sustainable design. But to stop there is to miss the profound depth of their vision. This was not a municipal water project, it was a spiritual circulatory system. The alignment of certain channels at Machu Picchu corresponds with solstice sunrises, so that the first light of the longest day would illuminate the flowing water in a specific fountain. The sound of water was carefully orchestrated, channeled to create soothing murmurs in ceremonial spaces, integrating its music into rituals. Water was not just channeled, it was celebrated at every turn, its aesthetic and acoustic properties considered as vital as its practical use. This reflects a holistic philosophy where engineering served to honor and amplify the natural world, not simply exploit it. The fountains were not just functional, they were places of reverence for the life-giving element. This integration of utility, beauty, and sacred meaning points to a principle we are only now, with our focus on green infrastructure and biophilic design, beginning to rediscover that the most resilient systems are those that work in concert with ecological and even spiritual balances. The water's journey through stone channels mirrors the builder's own journey of knowledge, a path that did not end with construction, but began a conversation with time itself. The stones themselves were the only textbooks they ever needed. This is the heart of the mystery. How did a civilization without a single blueprint, without a written manual of any kind, coordinate the construction of monuments that still defy replication? The answer lies not in libraries, but in a living chain of mentorship, in a system where knowledge flowed from hand to hand, from master to apprentice, in the very dust of the quarry and on the slopes of the mountain. These master builders, known as Kamayocs, were the guardians of a sacred craft. They did not teach from a page, they taught from presence. An apprentice learned not by studying theory, but by standing beside his teacher for years, feeling the vibration of a hammerstone striking granite, learning the subtle sound that signaled a perfect fit, memorizing the heft and grain of different stones through his own calloused hands. This was knowledge written in muscle memory and sensory experience, a language spoken through touch, sound, and ritual. Complex geometric principles for fitting polygonal stones were not equations, they were rhythms, patterns sung in work chants that synchronized labor and encoded techniques. The stories of how the mountains were formed, the myths of Pachamama, these were not mere folklore, they were containers of practical wisdom, embedding lessons about geology, water flow, and seismic safety within a narrative framework that ensured they were remembered and passed on. To build was to participate in a living story, where every stone laid was a verse in an epic poem of communal creation. This form of learning created a profound, embodied intelligence specific to that place, to those stones, to the very breath of the Andes. It was a wisdom inseparable from its context. A master Kamayoc from Cusco could read the granite of his local quarry like a familiar face, knowing exactly how it would fracture, how it would weather, how it would respond to the unique seismic pulse of his valley. This deep, localized knowledge is what modern engineering, for all its power, finds so difficult to capture. We excel at creating universal principles, standardized codes that can be applied anywhere in the world. We translate everything into abstract symbols, numbers, and digital models. But in doing so, we often lose the tacit, felt understanding that comes only from generations of intimate, uninterrupted dialogue with a specific piece of the earth. You can measure the angles of a trapezoidal doorway with a laser and replicate it exactly, but if you do not understand the why that was learned through centuries of observing earthquake damage, you have copied the shape but missed the soul. The catastrophic disruption brought by conquest shattered this unbroken chain of apprenticeship. The masters were lost, the apprentices scattered, and the songs fell silent. The knowledge which had always lived in the doing suddenly had no one left to do it. What remains are the silent, patient stones, a testament to an intelligence that was communal, embodied, and passed from heart to hand rather than from page to eye. This loss forces us to confront a humbling gap in our own systems of preservation, for we have saved their monuments in photographs and scans, but the living wisdom that built them has evaporated into the thin mountain air. It suggests that the greatest structures are not built from material alone, but from the continuity of a shared mind, a continuity that, once broken, leaves behind a mystery as solid as granite and just as enduring. The mountain itself was the first and most critical workshop. Before a single stone could be fitted or transported, it had to be carefully liberated from the living rock, a process that reveals a startling blend of patience and sophisticated physics. At quarries like Cachicota, which fed the colossal project at Ollantaytambo, the landscape tells a silent story. You can still see the ghosts of unfinished blocks, their outlines emerging from the cliff face like sleeping giants, surrounded by the faint scars of ancient tools. This was not a process of violent extraction, it was a slow, deliberate negotiation. The builders likely began by identifying natural fracture lines in the granite, the mountain's own seams of weakness. To encourage a clean break, evidence suggests they employed a technique known as thermal shock. Workers would build a fire directly along a desired fracture line, heating the stone until it expanded. Then they would douse the hot rock with water, causing it to contract rapidly. This dramatic temperature shift created immense internal stress, coaxing the stone to crack precisely along the intended path. It was a way of asking the mountain to release its bounty rather than demanding it. Once a preliminary fracture was established, the real artistry began. Using handheld hammerstones of harder rock and simple bronze chisels, they would then peck and grind channels along the line, deepening the natural fault. By repeatedly driving wooden wedges into these channels and soaking them with water, the expanding wood would generate steady, immense pressure, slowly and cleanly prying the multi-ton block free from its birthplace. This method stands in stark contrast to our modern approach. Today, we might use diamond-tipped saws that create wasteful slurry and heat-damaged edges, or explosives that shatter the stone's crystalline structure and create unpredictable fractures. The ancient technique was quieter, slower, and remarkably gentle, preserving the innate strength and integrity of the stone from the very first moment. The goal at the quarry was not to create a finished product, but to perform the initial rough shaping. By skillfully detaching a block that was already close to its intended final form, they dramatically reduced the sheer mass that would need to be hauled across valleys and up mountainsides. Every ounce of excess stone left at the quarry was an ounce of labor saved for 1,000 workers on the transport route. This first step establishes a profound theme. The entire enterprise was built on foresight and minimization of waste. It was a conversation that started with listening to the mountain's voice, understanding its grain and its tensions, and then collaborating with those forces to achieve a shared goal. The quarry was not a site of plunder, it was a sacred studio where the raw material of eternity was first awakened. For the Andean builders, a stone was never just a stone. It was a huaca, a word that defies simple translation but means a sacred object, a place of power, a vessel for spirit. A spring could be a huaca, a mountain peak was certainly one, and so too were certain extraordinary stones. This belief was not a poetic afterthought, it was the very bedrock of their engineering philosophy. To move and shape these stones was not construction, it was a form of high ceremony, a sacred dialogue with a living world. Imagine the mindset of a master Kamayoc approaching a granite monolith in the quarry. He did not see an inert resource to be exploited. He saw a being with its own history and essence, drawn from the body of Pachamama. The act of carefully detaching it, perhaps using fire and water to encourage its release, was the first step in a ritual relationship. They were not extracting material, they were inviting a participant into a greater design. This perspective fundamentally changes how we interpret their most baffling techniques. Take the infamous polygonal masonry, those giant, irregular blocks fitted with impossible precision. From a purely practical view, it is a seismic marvel, but from a spiritual view, it becomes something more profound. Each uniquely shaped stone, with its multiple facets and angles, may have represented a specific sacred place or a cosmic principle. The process of fitting them together was not just solving a geometric puzzle, it was performing a ritual of unification. It was binding the spiritual energies of different huacas into a single, harmonious whole. The wall itself became a mosaic of power, a physical network of sacred relationships. This might explain why they avoided simple, repetitive shapes. A grid of identical blocks imposes a human order upon the world. Their irregular tapestry, in contrast, mimicked the natural landscape, a cosmos of infinite variety held together by an unseen, intelligent pattern. This spiritual intentionality infused every action with a level of care and precision that transcends what we would call structural necessity. When your work is a devotional act, when you believe the stone itself is a conscious partner, you do not cut corners. You listen, you adjust, you strive for a perfection that honors the spirit within the material. The patience required for the trial and error fitting of 100-ton blocks becomes not just a technical feat, but an act of deep reverence. This introduces a challenging idea for our modern world. Contemporary engineering is a marvel of efficiency driven by physics, mathematics, and cost-benefit analysis. We build incredible things, but the process is largely secular. The primary goals are safety, function, and economy. For the Andean builders, the goals were harmony, durability, and spiritual alignment. Some theorists propose that this transcendental dimension, this sacred care woven into every step, is the intangible ingredient that accounts for the uncanny resilience and enduring harmony of their structures. It was a form of quality control not governed by a foreman's checklist, but by a collective spiritual commitment. To truly understand the how of their technique, we must first appreciate the why of their worldview. The stone accepted the builder's hand because the builder first honored the stone's spirit. This fusion of sacred purpose and practical mastery raises a final, pivotal question. If their knowledge was so profound and so deeply embedded in their culture, how could it simply vanish from the earth? The answer lies in a sudden and catastrophic severing of the living thread of memory. The silence of the quarries and the stillness of the walls hide a vibrant, living truth. These were not monuments built by a faceless state, but by a society in motion, a breathtaking symphony of coordinated human energy. To understand the scale, picture the logistics of moving a single 100-ton block from quarry to mountaintop. This required not hundreds, but likely thousands of individuals, all working in precise, rhythmic unison. They had no cranes, no trucks, no centralized command center with radios. What they had was a social system so elegantly woven into the fabric of community life that it turned monumental labor into a shared, rotational duty. This was the Mita system, often described as a labor tax, but that translation falls tragically short. It was not an extraction, it was an exchange, a cornerstone of reciprocal obligation that bound the community to the state and to each other. In return for contributing a portion of their time to public works, which included building temples, roads, and terraces, communities received security, access to stored food in times of shortage, and the profound social prestige of contributing to a sacred, enduring legacy. Your service was temporary, rotational, and seen as an honor that benefited your entire lineage. This framework transforms the image of construction from one of coerced toil to one of communal pilgrimage. Imagine the scene. From villages across a province, teams would arrive for their rotational period. They brought their own tools, their traditional knowledge, and were organized into groups based on their home regions, creating a sense of familiar camaraderie amidst the grand endeavor. The coordination of this flow of people is a managerial miracle that stands equal to the stonework itself. Planners had to calculate not just the number of hands needed to pull a rope, but the number of mouths to feed, the shelters to build on remote mountainsides, the tools to maintain, and the rotation schedules that allowed agricultural life back home to continue uninterrupted. They managed supply chains for food like dried potatoes and maize, and for materials like rope and abrasive sand, across some of the most punishing geography on Earth, all without written records or digital spreadsheets. This was project management encoded in oral tradition, administered through a trusted chain of local leaders. The motivation was multifaceted. Yes, there was a sense of duty to the Sapa Inca, the divine ruler. But deeper still was the spiritual imperative. To work on a temple was to directly serve the gods, to ensure the sun would rise and the rains would come. It was to literally weave your community's effort into the eternal fabric of the cosmos. The absence of widespread evidence for slavery or mass coercion in these projects is in many ways more puzzling to modern analysts than the fitting of the stones. Our history is littered with examples of megaprojects built on the backs of the oppressed. Here, the evidence points to something different, a collective will. Modern engineering can use software to perfectly model the forces needed to move a megalith. We can optimize schedules and resource allocation with artificial intelligence. But what algorithm can code for genuine shared purpose? What Gantt chart can capture the motivational power of believing your labor literally holds the universe in balance? We can replicate the physical act, but we cannot replicate the cultural and spiritual ecosystem that made thousands of people volunteer their sweat for a vision that would outlive them by centuries. This reveals the monument's dual nature. It is a triumph of civil engineering, yes, but perhaps even more so, it is a towering achievement in social engineering. The true foundation of these wonders was not the crushed gravel beneath the walls, but the intricate, reciprocal bonds of an entire society working as one. The stones were not meant to be silent. Beyond their visual grandeur and seismic intelligence, the ancient builders wove a hidden layer of sensory experience into the very fabric of their architecture, a layer we are only beginning to hear. Emerging research points to a startling possibility that some of these structures were deliberately engineered for sound. Walk through certain doorways at Machu Picchu or stand before specific niches in the Coricancha, and you might notice an unusual acoustic effect. Your own voice seems to change, becoming clearer, more resonant, or strangely focused. This is not an accident of stone placement. It appears to be a feature. Archaeoacoustics, the study of sound in ancient sites, suggests that walls were angled and spaces shaped to create specific sound reflections. A speaker standing in a particular spot might find their voice amplified and projected to a gathered crowd without any effort, while other niches could create a whispering gallery effect, carrying a secret message from one end of a chamber to the other. The builders seemed to understand that architecture could shape not just space, but the very sound that moved through it, using it to enhance ritual, communication, and authority. This sonic engineering reaches its most enigmatic expression with the so-called ringing stones. At several sites, including Ollantaytambo, there are specific andesite blocks that, when struck with another stone, produce a clear, metallic ring, a high-pitched tone that resonates like a bell. These are not isolated quirks of geology. They appear to be carefully selected and intentionally placed. The implication is profound. It means the builders were testing the acoustic properties of their materials, choosing stones not only for their strength and fit, but for their song. This integration of acoustics is a concept we associate with the most advanced modern concert hall design, where every surface is calculated to carry music with perfect clarity. For the Andean builders, the purpose was likely spiritual and experiential. Imagine a ceremony where a priest strikes a ringing stone, its pure, otherworldly tone vibrating through the plaza and into the bones of the participants. The sound itself becomes a sacred tool, a way to shift consciousness, to mark a moment with a sensation that is felt as much as it is heard. It creates an immersive environment where architecture activates multiple senses at once. This sonic dimension offers a tantalizing clue to those old legends of stones being moved by song or sound. While we cannot literally sing a 100-ton block up a mountain, the persistent myth may be a cultural memory of the power of rhythm and resonant frequency. Coordinated work chants would have been essential for synchronizing the pull of thousands on a massive rope, their unified voices creating a rhythmic pulse that maximized collective force. More intriguingly, if they understood that certain frequencies could make materials vibrate in specific ways, could they have used sound to test the integrity of a stone, or to find its resonant point during the fitting process? The ringing stones stand as physical proof that they listened to their materials with an incredibly refined ear. This holistic philosophy, where a structure must be visually harmonious, tectonically resilient, and acoustically alive, reveals a design principle that feels almost alien in its completeness. For them, a temple was not just a shelter, it was an instrument. Its stability was judged not only by the eye and the earthquake, but by the echo. To walk among these ruins in silence is to miss a fundamental part of their purpose. We must learn to listen again, to hear in the lingering resonance of a struck stone the echo of a civilization that built for the ear as meticulously as it built for the ages. Geometry was their silent alphabet, written not on parchment but in the very bones of their buildings. While they left no textbooks filled with equations, the structures themselves are a masterclass in applied mathematics. Everywhere you look, from the grandest temple to the humblest storehouse, you see the same elegant, purposeful shapes repeating. The trapezoidal doorway is the most famous example, but this principle extends far beyond. Walls themselves often lean inward slightly, creating another, larger trapezoid in their profile. Room dimensions follow consistent ratios, and the layouts of entire complexes appear governed by a hidden sense of proportion. This was not random artistry, it was a sophisticated practical mathematics of form, a language where shape directly communicated strength, stability, and sacred meaning. They understood through generations of trial and observation that certain angles distributed weight more efficiently, that specific proportions created spaces that felt both imposing and intimate. This knowledge system is what scholars call ethnomathematics, a mathematics born from and embedded within a specific culture and its daily needs. Their unit of measurement was not an abstract meter defined by a distant laboratory. It was the human body itself. Distances were likely measured in arm spans, in hand widths, in the lengths of a pace. This created an architecture intrinsically scaled to the people who used it. More profoundly, their geometry was often calibrated by the heavens. The angles of walls at sites like Machu Picchu frequently align with solstice sunrises or the rising of key stars. A building's proportions might mirror the cyclical patterns they observed in the cosmos, making each structure a microcosm of the universe. This mathematical language was recorded and transmitted, but not with pen and paper. They used the Khipu, a complex device of knotted cords. While we once thought these were merely accounting tools for tracking crops or livestock, ongoing research suggests they could encode far more sophisticated data, possibly even narrative information or architectural plans. The patterns of knots, their positions along the string, the colors and twists of the cords, may have served as a three-dimensional blueprint, a tactile database that could be read by trained record keepers. This highlights the fundamental difference between their mathematical worldview and our own. Modern engineering relies on abstract universal constants and calculus, on formulas that exist independently of the physical world. Their mathematics was embodied and experiential. It lived in the swing of a pacing stride, in the shadow cast by a gnomon at noon, in the tension of a chord being measured for a foundation line. To replicate the perfect fit of a polygonal joint today, an engineer might use a three-dimensional laser scanner to create a digital model, then program a robotic stone cutter. The ancient master builder achieved the same result through an intuitive, tactile understanding of geometry, refined by a lifetime of feeling stone against stone. He thought in relationships, not in vectors. He solved for harmony, not just for load. This is why our attempts to copy their techniques often feel hollow. We can duplicate the outward form with machined precision, but we are speaking a different mathematical language. Ours is detached and digital. Theirs was woven into the rhythm of the body and the cycles of the sky. We have the calculus to prove their walls are strong, but we lack the embodied wisdom to understand why those specific angles also make the space feel sacred. The stones obey a logic that is both impeccably rational and profoundly human, a code we can measure but cannot fully decipher. This lost language of shape and proportion suggests that their greatest secret was not a supernatural power, but a different way of knowing, one where mathematics was not a separate science, but the very grammar of building a living world. This durability creates a profound paradox for our modern world. We stand before walls that have weathered half a millennium without a caretaker, while we watch our own buildings, engineered with the full might of contemporary science, require constant, costly repairs within a single lifetime. The contrast is not just striking, it is a direct challenge to our assumptions about progress. The ancient approach was a slow, deliberate investment in permanence. Every polygonal joint fitted without mortar created a seal so tight that rainwater could not seep in, freeze, and expand to crack the stone from within. Their seismic flexibility meant the structure dissipated energy rather than accumulating microfractures with each tremor. They used dense, local stone that had already endured eons of mountain weather, ensuring it would only continue to patina gracefully, not crumble. This was architecture designed for a timeline measured in centuries, where the true cost was calculated not in currency, but in generations of sustained effort. Our modern construction paradigm often operates on a different calculus altogether, one that prioritizes speed, initial cost, and immediate function. We rely on materials like reinforced concrete, which is incredibly strong under compression but vulnerable to the insidious creep of moisture. When water penetrates and reaches the steel rebar inside, it rusts, expands, and causes the concrete to spoil and crack from the inside out. Our structures are rigid, fighting seismic forces head-on, which can lead to stress concentrations and hidden damage. We build for code compliance and projected lifespans that feel shockingly brief compared to the legacy of the Andes. This divergence reveals a critical misstep in many of our attempts to replicate these ancient wonders. We become fascinated by the form, the iconic look of the polygonal wall, and try to recreate it using modern shortcuts. We might use power tools to shape concrete blocks into irregular polygons and stack them with a thin layer of mortar, believing we have captured the essence. But in doing so, we have completely missed the holistic function. The original was a monolithic, flexible, breathing entity. Our replica is a rigid assembly of weaker parts glued together, destined to fail along the very mortar lines we introduced. The ancient builders did not separate the material from the method or the design from the environment. Their philosophy was integrated, where every choice, from quarry to placement, served the singular goal of harmonious endurance. Their structures do not just stand on the land, they have become of the land, their stones settling and weathering in a way that feels less like decay and more like a deepening relationship with the mountain. This invites a quiet but urgent question for our own time. Are we building for the next quarterly report or for the next millennium? The silent stones of the Andes suggest that true resilience cannot be rushed, and that longevity might require us to listen once more to the patience of the earth. High above the modern city of Cusco, a fortress of stone teeth bites into the skyline. This is Sacsayhuamán, and to walk its zigzagging ramparts is to stand before the ultimate expression of a lost engineering language. Here, every principle we have explored converges into a single, overwhelming testament. The polygonal masonry is not just present, it is perfected. Stones the size of small houses, some weighing over 120 tons, are fitted together in a dizzying, three-dimensional puzzle. The walls curve and jut in a sawtooth pattern, a design that served a devastating military purpose, forcing any attacker into deadly crossfire, while also mirroring the sacred lightning bolt of the Inca deity, Illapa. This was architecture that served three masters at once, the general, the priest, and the astronomer, without compromising a single one. The Spanish conquistadors who witnessed it could not process what they saw. Men who had built castles in Europe declared it the work of demons because their own understanding of construction offered no other explanation. How could humans without iron or draft animals have assembled this? The answer lies in the very details that baffled them. Look closely at a joint between two of these colossal blocks. The fit is so intimate, so complete, that over centuries of seismic activity, the stones have not shifted apart. They have actually polished one another through microscopic movements, sealing themselves even tighter. The foundation is a masterpiece of terraced earthworks and deep gravel beds, anchoring the entire structure to the mountain in a way that lets it sway as a single, flexible unit. And its positioning is no accident. Key walls and doorways align with the rising and setting sun on solstices, transforming the fortress into a giant stone calendar, a watchtower over both the earthly valley and the celestial cycle. Modern efforts to decode its construction have run the full gamut of technology. Engineers have created intricate computer models to calculate the forces involved. Teams of experimental archaeologists have tried to replicate the process on a small scale, using river cobbles to peck away at granite, slowly shaping a single stone over months of backbreaking labor. While these experiments prove the basic techniques were possible, they also reveal the staggering gap in scale and efficiency. No modern team, even with the advantage of hindsight and scientific method, has come close to rebuilding a section of Sacsayhuamán that matches its scale, precision, and speed. The project would be prohibitively expensive and time-consuming by today's standards, requiring a small army of dedicated artisans working for decades. This is the core of the Enigma. We can understand the individual notes, but we cannot reproduce the symphony. We can grasp the physics of a single fitted joint, but we cannot mobilize the social and spiritual orchestra required to compose an entire mountain. Sacsayhuamán, therefore, is more than a ruin. It is a permanent question carved in andesite. It asks us what we value: It challenges our definitions of efficiency, for a project that took generations to build has endured for half a millennium with near-zero maintenance. It stands as proof that the techniques of its builders were not just clever tricks, but components of a complete and cohesive system. A system where the stonecutter's patience, the astronomer's calculations, and the community's shared faith were all part of the same blueprint. To stand in its shadow is to feel the presence of that vanished cohesion, a harmony of purpose we can measure, admire, but still, stubbornly, cannot rebuild. But the genius of the Andean builders was not confined to stone alone. At a site called Moray, the earth itself becomes the canvas, and the engineering question shifts from how to build a structure that lasts to how to build an environment that teaches. Here, nestled in a highland basin, are a series of enormous circular terraces, descending like giant stone bowls into the ground. These are not defensive walls or temples, but something perhaps more revolutionary, a laboratory for life itself. Each concentric ring plunges deeper, creating a stunning gradient of temperature and humidity. From the warm, sun-bathed rim to the cool, shaded depths, the difference can be as much as 15 degrees Celsius or 27 degrees Fahrenheit. In a single, breathtaking depression, the builders replicated the climatic conditions of coastal valleys, mid-altitude slopes, and high mountain plains. This was no ordinary farm. It was a controlled experiment on a monumental scale, an agricultural research station carved directly into the living earth. The purpose seems clear: to test and adapt crops. By planting the same strain of potato or maize at different levels, they could observe which varieties thrived in which microclimate, selectively breeding for hardiness, yield, and taste. It was a slow, patient form of bioengineering that allowed them to domesticate thousands of potato varieties and prepare crops for transplantation across their vast, vertically diverse empire. Yet the true marvel lies not in the concept but in the execution. To carve such perfect, radiating circles into unstable hillside soil without causing catastrophic collapse required a deep, intuitive grasp of geotechnical engineering. The retaining walls for these terraces are masterpieces of dry stone construction, but they serve a different master than those at Sacsayhuamán. Here, the primary enemy was not seismic force, but hydrostatic pressure. Water saturating the soil behind a wall creates immense, pushing weight. The builders countered this with a hidden innovation: sophisticated drainage. Behind each stone wall, archaeologists have found deep layers of crushed rock, gravel, and rich topsoil. This was a carefully engineered filtration system. When rain fell, it would percolate down through the soil, hit the gravel layer, and be channeled away through hidden conduits before it could build up dangerous pressure. The walls themselves were built with a slight inward tilt and with stones that interlocked just as precisely as their polygonal cousins, creating a flexible, breathing barrier that could adjust to the settling earth. This integration of hydrology, soil science, and structural integrity is what kept these giant earthen laboratories stable for centuries. Modern agricultural science achieves controlled environments with glass greenhouses, computerized irrigation, and artificial heating and cooling, all requiring constant energy input and complex maintenance. Moray achieved a similar passive climate control using nothing but geometry, elevation, and an exquisite understanding of natural systems. It represents a pinnacle of applied environmental intelligence, where the goal was not to dominate nature, but to collaborate with it to create a space where the land itself could reveal its secrets. This shifts our understanding of these builders from master stonemasons to master ecologists. They were not just constructing monuments to their gods, they were engineering resilience into the very food chain of their civilization. The terraces of Moray stand as a quiet, circular testament to a different kind of power, the power to converse with the climate and to shape the future not in stone but in seed. Perhaps the most fragile link in their entire chain of knowledge was not stone or rope, but memory itself. This brings us to the enigmatic Khipu, a system of knotted cords that may have been the closest thing they had to a project manager's hard drive. For decades, scholars viewed these intricate textile devices as simple accounting tools, a way for administrators to tally quantities of grain, livestock, or people. But a growing wave of research is challenging that limited view, suggesting that some quipus were far more sophisticated. The patterns are too complex, the variations in color, cord twist, and knot placement too deliberate to represent only numbers. Some experts now propose that certain quipus could encode narrative information, stories, laws, or even the engineering instructions for building a place like Sacsayhuamán. Imagine a master builder, a Kamayoc, unrolling a Khipu not to count potatoes, but to review the sequence for fitting a particular polygonal stone. The main cord might represent the foundation line. Subsidiary cords hanging from it could indicate specific stones, with knots denoting their order of placement. The type of knot, its position along the string, the direction of its twist, even the color of the cord dyed from specific plants. Each variation could hold a specific meaning, a piece of technical data. A red cord might signify a stone from the North Quarry. A series of figure 8 knots could indicate a trapezoidal angle, and a specific color combination might reference a celestial alignment for a doorway. This was a three-dimensional, tactile database, a physical object you could feel in your hands, run through your fingers, and interpret through a trained, embodied understanding. It was a non-written blueprint system perfectly suited to a culture where knowledge was transmitted orally and through direct demonstration. The Khipu did not replace the master's teaching, it complemented it, serving as an aide-mémoire, a checklist, and a portable record all in one. Compare this to our modern digital blueprints. We store immense complexity in computer files, but that data is fragile, locked behind specific software and hardware that becomes obsolete within years. A power surge can erase centuries of theoretical knowledge in an instant. The Khipu, in contrast, was durable, made of enduring cotton or camelid fiber. It was portable, easily carried by a runner across the empire's road network. Most importantly, it was integrated, its meaning only fully unlocked by a trained reader who also held the oral keys to its interpretation, the stories, chants, and principles passed down from teacher to apprentice. This integration is precisely why its loss is so catastrophic. The Spanish conquest targeted and destroyed these devices as idolatrous objects, and the specialized class of readers, the Khipu Kamayocs, were lost or silenced. Today, hundreds of quipus survive in museums, but we can only decode a fraction of their numerical content. The vast majority remain silent, their narratives and instructions mute. This means we have not just lost a set of knots, we have lost the very project management manual for these impossible builds. We are left with the breathtaking final product, the stone symphony, but the conductor's score has been burned. The Khipu represents the ultimate paradox of their achievement, a system of information storage so elegant and resilient that it outlasted the civilization that created it, yet so personally encoded that its deepest secrets vanished with the last keeper of the code. It stands as a haunting reminder that the greatest structures are built not just on stone, but on stories, and when the stories are cut, even the most solid walls become a language we can no longer speak. The arrival of a new world order did not come with blueprints, but with swords and scriptures. In the 1500s, Spanish conquistadors and priests crossed the mountains, bringing a vision of empire and faith that saw the existing order not as a civilization to be understood, but as a pagan kingdom to be dismantled. This collision was not merely political, it was a direct assault on the living heart of Andean knowledge. The master builders, the Kamayocs who held the tactile wisdom of stone and sky in their hands, faced a brutal fate. Many were lost to the conflicts and illnesses that swept the land. Others were forcibly displaced, enslaved to work in mines, or stripped of their sacred roles. In a single generation, the unbroken chain of apprenticeship that stretched back centuries was violently severed. The songs that guided the work fell silent, the hands that could read a stone's grain were stilled, and the sacred sites themselves became targets. Temples like the Coricancha were stripped of their gold and masonry to furnish the very churches of the new faith, a physical metaphor for the attempted overwriting of one world view by another. What we explore today in the quiet ruins are not abandoned buildings, but the silent, surviving shells of a once vibrant intellectual tradition. The Spanish, for all their own architectural mastery with Gothic arches and Renaissance plazas, stood before these achievements in genuine awe. Chroniclers wrote with a mix of admiration and theological unease, struggling to explain how a people they considered inferior could create works that seemed to defy the laws of physics and time. Their solution was often pragmatic and telling. In Cusco and beyond, they frequently chose not to demolish the indestructible Inca foundations, but to build their own colonial structures directly on top of them. The seamless stonework became the sturdy basement for Baroque cathedrals, a literal layering of the new upon the impossibly durable old. This act acknowledges a profound truth: they could marvel at the result, but they could not replicate the process. The techniques were not lost because they were too complex for any human mind to comprehend. They were lost because the continuous cultural vessel that contained them, the society that nurtured the Kamayocs, honored the Mita system, and spoke the language of sacred Huacas, was shattered. The knowledge was like a delicate, complex piece of pottery, fired to perfection over generations, and the conquest was the hammer blow that broke it into fragments. We have recovered many of the shards, the physical structures, the quarry sites, the terraces. We can analyze their composition and measure their angles. But the potter's wheel, the recipe for the clay, the feel of the kiln's heat, and the stories told during its making, that living context evaporated. Our modern search to understand these techniques is therefore not just an engineering puzzle. It is, in large part, an act of archaeological recovery, a patient effort to glue those shards back together and infer, from their shape and fit, the outline of the magnificent whole that once was. We are trying to reconstruct a song from the echo that remains in the stones. The proof of their genius is written in the stubborn silence of modern laboratories. For decades, teams of archaeologists and engineers have rolled up their sleeves, determined to crack the code using the tools they believe were available: copper chisels, stone hammers, ropes, and sheer human effort. The results are humbling. In controlled experiments, skilled workers using replica bronze and stone tools can indeed shape a granite block. But the timeline is staggering, transforming a theoretical possibility into a logistical nightmare. To create a single, modestly sized stone with a flat surface and beveled edges can take a team weeks or even months of relentless, sun-up to sundown labor. When you scale this up to a monolith weighing 50 or 100 tons, the math collapses our conventional understanding of ancient project management. It suggests either a society with a patience we can scarcely comprehend, or, more likely, the use of supplemental techniques we have yet to rediscover, methods that acted as a force multiplier on human labor. The mystery only deepens when we leave the workshop for the mountainside. Attempts to transport large stones using teams of volunteers and log rollers, following the most accepted theories, have yielded mixed and often frustrating results. A stone that slides smoothly on a level, prepared track can become an immovable, dangerous object on a slope. Teams of 100 people might find they need 200, or that the type of wood used for rollers splinters under the immense pressure, or that the rhythm of pulling must be perfectly synchronized to gain mere inches of progress. These practical trials reveal a hidden layer of sophistication. The original builders likely employed not one, but a shifting combination of techniques, ramps, slideways, rocking motions, and perhaps even temporary earthen causeways that we have not fully considered. The most revealing evidence, however, comes not from our attempts to build, but from our most advanced tools of measurement. Three-dimensional laser scanning of the polygonal walls at sites like Ollantaytambo has produced a digital revelation. What appears to the naked eye as a clean, flat joint is, at a microscopic level, a landscape of intentional subtlety. The contacting faces are not perfectly flat planes. They often feature slight, deliberate convexities and concavities. This means the stones do not just meet at their edges, they cup and cradle one another, creating a complex, three-dimensional interlock that goes far beyond a simple puzzle piece fit. It is a masterpiece of passive engineering, ensuring that under seismic load, the stones settle more deeply into their embrace rather than pulling apart. This level of precision, achieved on irregular 100-ton blocks, defies explanation through simple trial and error. It points to a quality control and measurement system of incredible refinement, perhaps involving taut chords, water levels, and shadow casting that we are only beginning to appreciate. So where does this leave our modern quest for replication? We can, with immense effort and modern insight, produce a wall that looks Inca. We can shape irregular stones and stack them tightly. But the process lacks the original's terrifying efficiency and holistic grace. Our replicas are academic exercises, their cost and time requirement proving them economically and practically impossible on the original scale. What we cannot replicate is the seamless integration, where the quarryman's knowledge of fracture lines informed the dragger's route, which in turn was planned by the astronomer's alignment. We cannot replicate the cultural engine, the Mita system, that turned this monumental labor into a rotating civic duty rather than a life sentence of toil. And we cannot replicate the spiritual imperative, the belief that fitting these stones was a sacred act of cosmic harmony, which may have inspired a level of care and precision that no wage or deadline could ever motivate. Every failed experiment, every staggering time calculation, every laser scan that reveals new complexity does not diminish the ancients, it elevates them. It confirms that their techniques were not primitive steps on a ladder leading to us, but a parallel peak of human achievement, reached by a different path altogether. The gap is not one of intelligence but of worldview. We seek to conquer material with force and speed. They sought to collaborate with it through patience and profound listening. This leaves us with a final, resonant thought. If we cannot rebuild what they built, perhaps the greater lesson is not in the how, but in the why. Their silent legacy is now finding a voice in the steel and glass of our modern cities. While we may never rebuild Sacsayhuamán, the philosophical DNA of its construction is being woven into the fabric of contemporary design, sparking a quiet revolution in how we think about resilience. This influence is not about literal replication, but about biomimicry, the art of learning from nature's time-tested strategies. The ancient builders were masters of this, and today's architects are finally beginning to listen. In earthquake-prone regions from Japan to California, the principle of seismic flexibility, so elegantly demonstrated in those dancing polygonal walls, has inspired a fundamental shift. We no longer try to fight every tremor with brute strength alone. Instead, engineers design skyscrapers with massive pendulum dampers that sway in opposition to the building's movement, absorbing energy just as those interlocked stones did. Base isolation systems, where a building rests on flexible pads of rubber and lead, allow the ground to shudder while the structure above remains stable, a high-tech echo of the gravel foundations and flexible joints used 500 years ago. The goal is the same, to move with the force, not against it, and the ancient Andes provided a masterclass in this passive, intelligent approach. Beyond seismic safety, the hydrological genius of sites like Machu Picchu is being re-examined through the lens of sustainability. In an era of increasing water scarcity and a push for off-grid systems, the ancient network of stone channels and fountains is a textbook example of passive, gravity-fed water management. Modern landscape architects and civil engineers study these systems not to copy them stone for stone, but to understand the underlying principles: slow capture, minimal intervention, and integration with the natural topography. This inspires contemporary designs for rain gardens, bioswales, and natural filtration systems that manage stormwater without pumps or complex machinery, allowing landscapes to clean and channel water much as the mountain itself does. It is a return to working with the hydrological cycle rather than forcing it into concrete pipes. Even the aesthetic and structural lesson of polygonal masonry is experiencing a renaissance. In high-end landscape architecture, a renewed interest in dry stone walling built without mortar draws direct inspiration from the Andean example. These walls are celebrated not just for their beauty, but for their environmental friendliness, their permeability for drainage, and their habitat value for insects and small animals. They represent a move away from sterile, manufactured barriers toward structures that are of the land, blending seamlessly and enduring for generations with minimal maintenance. Each of these applications shares a common thread. They are not about finding a lost cheat code for construction, but about recovering a lost philosophy. The modern movement they inspire is one of holistic, context-sensitive design. It asks the questions the ancient builders began with: how does the wind move here? Where does the water want to go? What forces will this ground exert over a century? It prioritizes longevity over quick turnover and integration over imposition. The stones of the Andes, therefore, are more than a historical curiosity. They have become silent mentors in a global conversation about resilient living. They remind us that the most advanced solution is sometimes not the most complex new material, but the most profound understanding of an old one, and that building for a future of uncertainty might just require us to listen to the whispers of a very deep past. Yet these stones have also become a canvas for our own modern myths. In the search for answers, a different kind of story often emerges, one that points not to human ingenuity, but to otherworldly architects or a forgotten super-civilization. These are the tales of ancient astronauts, of a vanished Atlantean race, or of technologies so advanced they defy our physics. While they capture the public imagination, they create a fascinating and problematic paradox. On one hand, they acknowledge the sheer, breathtaking impossibility of what we see. The structures are so perfect, so baffling, that leaping to an extraterrestrial or ultra-ancient explanation feels, to some, like the only logical conclusion. Yet in doing so, these narratives inadvertently erase the very people who lived there. They take the monumental achievements of the Inca and their predecessors and hand them to a mysterious, often whitewashed other. It suggests subtly that the indigenous cultures of the Andes could not possibly have been the authors of their own legacy. Mainstream archaeology, built on decades of excavation, carbon dating, and cultural analysis, tells a different and far more compelling story. It sees a lineage of human genius, a slow accumulation of knowledge passed from parent to child, from master to apprentice over countless generations. Every trapezoidal doorway is not a mystery, but an answer, a solution refined through observing which shapes survived tremors and which did not. The perfect fit of polygonal stones is not magic, but the endpoint of 1,000 years of stonemasons learning to listen to the rock. This was not a sudden gift from the stars, but a hard-won dialogue with an unforgiving mountain. So why do the alternative theories persist with such power? Perhaps because they serve as a mirror to our own discomfort. They highlight just how extraordinary these human accomplishments truly are, so extraordinary that they stretch our credulity. They force us to confront a gap in our own understanding of what pre-industrial societies were capable of achieving. It is easier, sometimes, to imagine a fantastical intervention than to accept the profound patience, coordination, and intelligence of a people whose worldview was fundamentally different from our own. Engaging with these ideas, then, is not a diversion but a way to measure the scale of the real mystery. The truth, grounded in the evidence of quarry marks, tool fragments, and the living traditions of descendant communities, is remarkable enough. It asks us to expand our definition of human potential, to consider that mastery can be achieved not through complex machinery, but through deep cultural continuity and a sacred relationship with the material world. The stones do not whisper of aliens, they echo with the voices of thousands, singing in unison as they coax a mountain into the shape of a temple. That is a mystery far more worthy of our awe. The quest for answers inevitably leads us to a quiet but vital crossroads, one of responsibility rather than just curiosity. As modern researchers and engineers work to decode these ancient techniques, we must pause and ask a fundamental question: who truly owns this knowledge? The silent stones of Sacsayhuamán or the terraces of Moray are not merely inert puzzles for global academia to solve. They are the profound cultural heritage of living communities, the descendants of the very builders whose wisdom we so admire. For many Quechua and other Andean peoples today, these sites are not ruins, they are sacred landscapes, places where ancestors still reside, and where spiritual connection to Pachamama remains vibrantly alive. A stone block is not just a construction module, it can be a Huaca, a being with its own essence and history. This perspective fundamentally reshapes the entire endeavor of study. It means that every laser scan, every archaeological dig, every attempt to reverse engineer a method is, in essence, interacting with someone's heritage and sacred geography. The ethical dimension, therefore, becomes inseparable from the technical one. How should this research be conducted? The outdated model of outside experts arriving, extracting data and artifacts, and publishing findings far removed from the source communities is increasingly recognized as a form of intellectual colonialism. It repeats a pattern of taking without meaningful return. Ethical engagement demands a collaborative framework. This means involving descendant communities from the very beginning of research projects, not as passive subjects or laborers, but as essential partners and knowledge holders. It requires respecting indigenous knowledge systems, which may explain the purpose and meaning of a structure in spiritual and cosmological terms that complement the engineer's stress and strain analysis. This partnership ensures that research questions are relevant and respectful, and that the methods of investigation do not inadvertently damage the spiritual integrity of a place. Furthermore, the question of benefit is critical. If these ancient principles of seismic flexibility or passive water management are successfully decoded and adapted for modern earthquake-resistant construction or sustainable architecture, who stands to gain? Will patents and profits flow only to international engineering firms and universities, or will the descendant communities, the rightful inheritors of this intellectual legacy, have a stake in that application? Ensuring equitable benefit sharing is a concrete step toward correcting historical injustices. It acknowledges that this knowledge is not a free-floating scientific resource, but a cultural one, born from a specific people and place. Ultimately, this ethical layer adds a crucial depth to our understanding. It reminds us that the greatest mystery of these sites may not be a lost tool, but a lost relationship, a way of engaging with the world where technology, community, and spirituality were woven into a single, resilient fabric. To truly honor the builders, we must strive to honor not just what they built, but the living continuum of culture they built it for. The stones ask us not only how they were placed, but how we choose to approach them now. The search for understanding now moves from the mountain to the machine. The next great revelations about these ancient builders may not come from a new excavation, but from a new way of seeing. High above the cloud forests, aircraft equipped with LIDAR technology are sweeping the landscape with laser pulses. This light detection and ranging system penetrates the dense canopy, digitally stripping away centuries of overgrowth to reveal the ground beneath. What it uncovers is staggering, vast, hidden networks of roads, terraces, and settlements woven across the Andes like a colossal spiderweb. This is not just discovering a few new ruins, it is revealing the true continental scale of their planning. It shows an empire engineered not just in stone, but in entire landscapes, with a coordination that rewrites our maps and our assumptions about their logistical reach. The sheer density of this engineered terrain suggests a level of population management and environmental shaping far beyond previous estimates. LIDAR is proving that our most profound mistake may have been underestimating the sheer ambition of their vision, revealing that the iconic sites we know are merely the glittering nodes in a hidden, interconnected system that covered mountains. Alongside this bird's eye view, another form of artificial sight is examining the microscopic. Researchers are now feeding thousands of high-resolution, three-dimensional scans of polygonal stone joints into artificial intelligence systems. The goal is not to find a simple pattern, but to decode a complex, non-repeating algorithm of shape. The human eye can admire the fit, but the AI can analyze millions of data points, searching for underlying geometric principles, common angles, or stress distributions that might have guided the master Kamayocs. Could the placement of a 12-sided stone follow a logic based on celestial alignments or sacred proportions? A code too subtle for us to perceive. The AI acts as a digital apprentice, learning from the masters through their silent, stone language, and perhaps one day revealing the hidden grammar of their construction. This technological leap underscores a fundamental truth: no single expert holds the key. The path forward belongs to interdisciplinary teams where traditional boundaries dissolve. An archaeologist's understanding of ritual context must sit beside a modern stonemason's tactile knowledge of how granite fractures. A geologist's analysis of quarry sources must inform an engineer's model of seismic dynamics. Only by weaving these threads together can we hope to approximate the holistic mind of the ancient builder, for whom science, spirituality, and craft were a single, fluent discipline. Future experiments may even use virtual reality to simulate their perspective, allowing researchers to stand in a digitally recreated quarry or construction site, testing theories of leverage and sightlines with an embodied sense of place that blueprints cannot provide. This collaborative technological approach points toward a humbling shift in the quest. We are moving away from the romantic hunt for a single lost secret, a magical plant, or a forgotten tool. Instead, we are patiently assembling a holistic picture of an entirely different technological paradigm. It was a paradigm not of extraction and force, but of integration and symbiosis. Their engineering was deeply sustainable, built from local materials with methods that strengthened rather than depleted the land. It was profoundly resilient, designed to adapt and endure through centuries of upheaval. In an era facing its own crises of environmental strain and seismic uncertainty, these are not just historical curiosities. They are urgent lessons written in stone, waiting for us to learn the language. The future of this research, then, is not about rebuilding their past, but about discovering principles that could help us build our own future. The most elusive secret is not hidden in the quarry or the joint. It existed in the space between them, in the connections we can no longer see. We often search for a singular lost trick, a forgotten tool, or a magical plant sap, believing that if we could just find that one piece, the entire puzzle would snap into place. But this search is the ultimate distraction. The true, unreplicable genius of the Andean builders was not a collection of isolated techniques. It was a holistic system, a complete and seamless worldview where every action was woven into a larger, living tapestry. Think of it not as a toolbox but as a language. We might learn to pronounce a few of their words like polygonal or trapezoid, but we have lost the grammar that gave those words meaning and power. Their sacred cosmology was not separate from their logistics. The alignment of a temple doorway with the solstice sunrise was as critical to its construction as the angle of its walls. This was not an artistic flourish added at the end. It was a foundational design parameter, as essential as load-bearing calculations are for us. Their embodied mathematics lived in the swing of a pacing stride and the tension of a measuring cord, making geometry a physical, felt experience rather than an abstract formula on a screen. Their sophisticated logistics, the Mita system, was not just project management, it was a sacred reciprocal duty, a spiritual exchange that motivated thousands. Their empirical material science grew from generations of listening to how specific stones from specific quarries behaved during earthquakes, a deep dialogue with the mountain itself. And underpinning it all was a profound ecological ethic, a principle known as Ayni, or sacred reciprocity. You give to the earth, and in return, the earth sustains you. This was not a metaphor, it was a practical engineering philosophy. To take stone from a quarry was to perform ceremony, to give offerings. To channel water was to honor its spirit. Every act of construction was an act of balance, of maintaining a harmonious relationship with Pachamama. Modern engineering, for all its breathtaking power, operates within a different framework. Our disciplines are often siloed, secular, and specialized. A structural engineer focuses on stress, a hydrologist on flow, an architect on form and function. These experts may collaborate, but their work begins from separate domains of knowledge. Our technology is frequently imposed upon a site, designed to control and dominate the natural forces at play. We can, with immense effort and advanced tools, replicate individual components of the Andean system. We can laser-cut stones to fit like a puzzle. We can calculate astronomical alignments with satellite precision. We can even organize large workforces, but what we cannot replicate is the interconnected, spiritual worldview that made those components parts of a single, coherent, and enduring whole. The techniques were not just actions, they were expressions. The perfect stone joint was an expression of respect for the material spirit. The solstice alignment was an expression of harmony with cosmic order. The terraced landscape was an expression of gratitude and care for the source of all life. This integration meant that quality control was not enforced by a foreman, but by a collective spiritual commitment. A mistake was not just a structural flaw, it was a rupture in the sacred balance. This is why our modern replicas, however precise, feel somehow hollow. They have the shape but not the soul. They demonstrate the how, but they are silent on the why. The ultimate lesson from these silent mountains is not a set of instructions. It is an invitation to reconsider our own relationship with the world we build. It suggests that the most resilient structures emerge not from a desire to conquer our environment, but from a profound conversation with it, a conversation built on listening, reciprocity, and a humble acknowledgement that we are not separate from the forces we seek to harness. The stones endure not because they defeated time, but because they learned to speak its language. The final stone, then, is not one of granite but of perspective. We stand at the end of this exploration not with a solved equation, but with a deepened sense of awe. The enigma of the Andean builders resists a tidy conclusion because their legacy is not a puzzle to be solved, but a conversation to be joined. Their techniques whisper a humbling truth across the centuries, that the path of human ingenuity is not a straight, ascending line. It is a vast and branching tree where different cultures can reach towering heights by following entirely different branches of understanding. We possess tools they could never have dreamed of, satellites and supercomputers and alloys forged in zero gravity, and yet we look upon their dry stone walls with a sense of genuine mystery. Our most advanced engineering cannot easily replicate what they achieved with stone, rope, and an intimate knowledge of their world. This is not a failure of our science, but a testament to the depth and uniqueness of theirs. It proves that ancient wisdom is not merely a primitive precursor to our own, but can represent a parallel peak of achievement, reached through a philosophy we have largely forgotten. The perfectly fitted joints are far more than a clever seismic solution. They are the physical grammar of a lost dialogue, a profound exchange between a people and their mountain. Every stone was chosen, shaped, and placed not as an act of domination, but as an act of collaboration. Their engineering was never just about physics. It was infused with purpose, with a patience measured in generations, and with a sacred connection to Pachamama that transformed construction into ceremony. This integration of the practical and the spiritual, the technical and the ecological, is perhaps the most valuable secret they leave for us. It challenges the very core of how we think about building our own world today. We live in an age of incredible speed and disposable materials, where structures are often designed for decades, not millennia. The Andean example asks us to slow down, to listen to the land, and to consider the legacy we are carving into the earth. What would our cities look like if we designed them not just for efficiency, but for harmony? If we saw our materials not as inert resources, but as partners in a longer story? Their silent, enduring stones are an invitation to reflect. They remind us that the most resilient things we can build are not made from the strongest concrete, but from the deepest understanding. Let these mysteries inspire more than just wonder. Let them spark a curiosity about the other paths human genius has taken. If you found this journey into lost engineering as fascinating as I did, I would love to hear your thoughts in the comments below. Which ancient wonder, which other silent testament to human ingenuity, should we explore together next? Be sure to subscribe so you do not miss our next deep dive into the world's greatest historical mysteries. Thank you for watching.